Okay, let's do the review. So remember, there's an exponent of 1, so you multiply the exponents. 4 to the 4th, x to the 12th, 256, x to the 12th. Next, we don't have a power raised to a power. We have multiplying same bases, except for the coefficients are different, so we multiply those as is. But here we're multiplying things with the same base, so you add their exponents. So when I adding a negative, so when I do this, I will get negative 36 x to the 4th. Over here, this is the same thing, they just have it in parentheses. So I multiply my coefficients. I have x times x, I have y to the 3rd times y to the 3rd. When I do this, remember there's an invisible 1 right there, so I add the exponents, and I get 15x squared, y to the 6th. This one, this is a power raised to a power, so I multiply my exponents, so I get w to the 15th. This one, I have a fraction. Guys, with fractions, you always want to simplify it first. I know I'm making noise. I'm taking off my jacket. There we go. So remember, that has an exponent of 1. So I'm going to subtract my exponents. Subtract my exponents. Subtract my exponents. When I do that, I get k to the 5th RT. To the 0 power, I don't have to do anything else because the whole thing is raised to the 0 power, so that comes out to 1. This one, is there anything on the inside of this set of parentheses that I need to simplify? No, there's not. So remember, there's an exponent of 1. Power raised to a power, I multiply my exponents. I multiply my exponents. And when I do that, I get 2 to the 4th, m to the 8th, j to the 12th, over 3 to the 4th, p to the 20th. So that's going to get me 16 m to the 8th, j to the 12th, over 81 p to the 20th. Okay, next, simplify this. Well, I have n's and m's in both the numerator and the denominator, so I'm going to subtract. Actually, yeah, let's go ahead and just subtract. So 3 minus negative 1, 1 minus 2. If I do that, I would get n to the 4th, m to the negative 1. When I get that, I get n to the 4th over m. Now, there is a different way that you could do this. The other way you could do this is move this upstairs. So I have n to the 3rd times n, m over m squared. So that would get me n to the 4th. There are more m's on bottom by 1. So whichever way you do it, you'll still come up with the same exact answer. Sorry, it is not wanting me to make this smaller. Come on. Why? Whatever, I can't make it smaller. Here we go. So on this one, now some of you might say, oh, we're going to simplify the fraction. But look at the numerator. The numerator has these. This is inside a set of parentheses. Remember, you have to do those parentheses. You have to deal with that before you can do the simplifying of the fraction. So 1 times 2, b to the third times 2 over a. Now, a squared over b to the sixth over a. Okay? I subtract my exponents, and I just get plain old a, b to the sixth. Still doesn't want. It's okay. So this one, guys, this automatically goes to 1. I don't even need to deal with that. There's no other x's, so that's going to move downstairs. Remember that those have exponents of 1. So y to the 3 minus 1, z to the 1 minus 4, and the x squared moves downstairs. I get y squared z to the negative 3 over x squared. So y squared over x squared z to the third. Now, could you have looked at it this way and the fact that there are more on the denominator, and so you could have had the z to the fourth minus 1 on the denominator? Sure. Okay. I simplify inside first. I don't care which way you do it. I'm going to move this downstairs. I'm going to move this upstairs. So n squared on top, n on bottom. Move this downstairs, move this upstairs. M to the third. I don't know why these aren't in alphabetical order, but they're not. Okay, so I'm going to simplify this. I get n2 minus 1, m3 minus 2, raised to the negative 1. So I get n to the first, m to the first, negative 1. So that's going to get me 1 over nm. There, that time it let me do it. Okay, so I'm going to simplify this. I look at my coefficients. Boys and girls, what is 3 divided by 3? It is 1. Okay, so I have b to the negative 3. I'm going to move that downstairs, but I'm going to move this upstairs. So I have b squared upstairs. I have b to the third, or try that again. That's an a to the fourth. Then I have b to the third that moved. I have b to the fourth that's already down there. Remember, there's an invisible 1 right here. So I have b squared on top, a to the fourth, b to the seventh. Okay, there's an invisible 1. This is going to become 1 over a to the fourth, b to the fifth. Because, guys, b times b over 2, 3, 4, 5, 6, 7. Cancel, cancel. There are 5 of them on bottom. Okay, this one. Okay, move upstairs, move downstairs, move upstairs. So I've got 3 y to the fourth, x to the fourth over 8 y to the third. Can't do anything with my coefficients. They stay the same. X to the fourth, because we like alphabetical order. We have 4 y's on top, 3 y's on bottom. Subtract those, and I get 1 y on the top. Okay. Actually, on this one, I'm not going to move it first. I'm going to actually multiply it first. I'm going to get negative 16. I'm going to add my exponents. Adding a negative is subtracting. Y to the negative 19, so y over y to the 19th. Did I say y over? 1 over. Okay, this one, 2y to the third. All of this is going to the denominator, so I'm not even going to write that yet. Then I have 2y, and then this goes to the denominator. So I have 2x to the fourth, y to the fourth, raised to the second power, and x. So up top, I have 4y to the fourth. On bottom, remember, we multiply the exponents. So 2 to the second power, x to the eighth power, y to the eighth power, x. Okay, guys, this is the same thing as 4. 4 divided by 4 is 1. So I have an invisible 1. I have y to the fourth over. There's an invisible 1 right there, so I get x to the ninth. I get y to the eighth. There are more y's in the denominator. What's 8 minus 4? 8 minus 4 is 4. Now, if you need to actually write that out and get this to tell you that it's in the denominator, that's perfectly fine. Okay, so this one, it's going to the denominator. This whole thing is going to the denominator, and this is going to the denominator. So I have 2 times 4 in the numerator. I have x. I have xy to the fourth, all raised to the third, and I have y to the third. Okay, remember there's a 1 there. So I get 8 over x, then I add x to the third, y to the 12th, y to the third. Can't do anything with coefficients, that just stays there. Add my exponents, remembering there's a little 1 there. Add my exponents, x to the fourth, y to the 15th. Okay, next. Oh, I can't make it smaller. Oh, there we go. Simplify the radical expression as much as possible. So we're taking the square root, okay? This is a square root. There's an invisible little 2 there. So what perfect square goes into this? 25 does. Oops. I don't know why I did that. Guys, I need you to understand that we need an even exponent. We need an even exponent. So, if I take the square root of each one of these things, if I take the square root of that, the square root of 25, nope. The square root of 25 is 5. You cannot take the square root of 3, so it stays there. The square root of x squared, guys, all you do is divide the exponent by 2. 2 divided by 2 is 1. And then that one goes underneath. Anytime you're taking the square root of something and that is an odd exponent, that means there's going to be 1 left underneath. Okay. Same thing here. Okay. This is going to be 81 times 2. That's already okay. This one, though. Okay, so if I'm taking the square root of each one of these, square root, square root. So I'm doing that. That means I've got 9. 2 cannot be taken the square root of. The square root of a squared is a. The square root of b to the fourth is b squared. All you do is divide the exponent by 2, b, and then c. This one, I'm taking the cubed root. That means that the exponent, when I do this, the exponents needed to be divisible by 3. This over here was the square root, so that's something to the 1/2 power. So that's why we needed something that was even, because 2 goes into all even numbers. Here, we need all of the exponents to come out to something that is divisible by 3. So we're going to do this. 2 goes into this 16 times. 2 goes into this 8 times. 2 goes into this 4 times. 2 goes into this 2. So I have 1, 2, 3, 4, 5. So I have 2 to the 5th. But I need it to be divisible by 3. Okay, so right now 2 to the 5th is not divisible by 3. That 5 is not. But 3 is. Remember, I would add those exponents. Adding those exponents would get me that 2 to the 5th. So now I have n to the 5th. So I'm going to do the same thing. N to the 3rd times n squared. Because I need my exponent to be divisible by 3. 9 is divisible by 3. So I leave it as is. I take the square or the cubed root. Oh no, I'm not even going to take the cubed root. I'm going to leave it like this. So if I was to, okay, I guess I have to write small. If I take 3 and I multiply it by 1/3, oh, I didn't actually write it, but that's okay. So if I do this, that's going to come out to 1. So I leave it. This one is going to come out to 1. This one is going to come out to 3. Oh, that's okay. I'll write it like that. Now, do you see how each one of these has a 1/3 on the bottom? That means you're still taking the cubed root. So that means I have a 2 squared in there, and I have an n squared in there. So I have 2m to the 3rd n cubed root of 4n squared. You can't take the cube root of that. You can't take the cube root of that. Okay, let's try this again. Okay, there's an invisible 2 there. So I need all the numbers that are inside, or sorry, all the exponents inside to be divisible by 2. So this one, let's see. Does 4 go into 1/12? Well, 12 is on the end, so that automatically means, look at that, 16 times 7. Okay, so I have a 10 on the outside. I'm taking the square root of 4 squared times 7, x to the 4th, y. I don't want that color, I want this one. This is divisible by 2. This is divisible by 2. So I have 10 times 4 times x squared. You divide the exponents by 2. Square root of 7y. So I have 40x squared, square root of 7y. This one, still doing the square root. Okay, I know 16 goes into that because 16 goes into 32. Oops. That'll get me 20. That'll get me 4 and 5. Okay, so I have 4 on the outside. I have the square root of 16 times 4 times 5. A to the 12th, that is an even exponent, so we don't need to do anything with it. This, on the other hand, is not an even exponent. We need to make it an even exponent by doing this. So b to the 10th times b. So I'm going to take the square root. So I have 4 that's already, that was on the outside already. Okay? I'm going to take the square root of 16, that's 4. I'm going to take the square root of 4, that's 2. 5, there's no square root of 5, so we write it underneath. This, I divide the exponent in half. Right here, I divide the exponent in half. And then b goes underneath. So 4 times 4 times 2, that's going to get me 32a to the 6th, b to the 5th, square root of 5b. Okay. We can do it this way too. It's the same thing, guys. So this is 9 times 5. This is 3 times 3. So 3 squared times 5, m to the squared times m, and then n squared. Guys, this is the same thing as taking the square root of. So if I multiply this 2 right here by a half, I'm going to get 1. I'm going to get a 1/2. I'm going to get a 1. I'm going to get a 1/2. I'm going to get a 1. All the ones that have 1 are going to come out here. Now, we never write this like this. We write it as the square root of this. Could we have looked at it differently from the very beginning? Sure. Could we have made it the square root of 45 m to the 3rd n squared? Yes. Does it matter? No. 9 times 5, m squared times m n squared. We're doing the same thing. The square root of 9 is 3. Can't take the square root of 5. Square root of m squared is m. Can't take the square root of just a plain m. And then n. You would have gotten the exact same answer. Okay, so this one. So, I don't know what this is. So, let's see. 8 is a perfect square, or a perfect cube, because we want cubes. 8 goes in that 21 times? Yes. And then we want this to be divisible by 3, so the x to the 12th, x squared, and that is divisible by 3. So I'm not going to write it there. I'm going to bring it down here a little bit more. So I'm actually going to rewrite this as the cubed root. Okay? 8 times 21, x to the 12th, x squared, y to the 24th. I have a 5 out front. The cubed root of 8 is 2. Can't take the cubed root of 21, so it stays underneath. The cubed root of x to the 12th. Divide the exponent by 3. You get x to the 14. Why 14? Nada que ver. 4. And my x squared goes here. Divide the exponent by 3, and I would get 8. So my answer is 10, x to the 4th, y to the 8th. Why did I do that? Cubed root of 21x squared. Now, if I had done it the other way with the exponent, that's fine. 2 to the 3rd times 21, x to the 12th times x squared, and y to the 24th, raised to the 1/3 power. So 5. So 3 times 1/3 get me 1, so I got a 2. So then I have 21 to the 1/3 power. 3 goes into 12 4 times. 3 doesn't go into 2, so that gives me an x to the 2/3 here. And 24 divided by 3 is 8. So 10 x to the 4th, y to the 8th, to the cubed root of 21x squared. So it still comes out to the exact same thing. Okay, over here, we're doing the 4th root. So I'm guessing 5 goes in there. 5 to the 4th is 625. 15 divided by 625. Oops, 25, not 20. Oh, 625 goes in 3 times. Now you may be saying, how do you know that? That 625 is 5 to the 4th power. Well, 5 times 5 is 25, and 25 times 25 is 625. Okay, so I need my exponents this time around to be to the 4th power. I mean, divisible by 4 is what I should say. 625 times 3. Oh, 4 goes into 16 evenly. Voila, that's okay. Doesn't go into 25 evenly, but it does go into 24 evenly. So I have 3x to the third, xy to the third. The 4th root of 625 is 5. 4th root of 3. I've got this 16 here, divided by 4. Get x to the 4th power. Divide the 24 by 4, so I get y to the 6th and y underneath. So 15x to the 5th, y to the 9th, and the 4th root of 3y. Okay, and one more. So I have negative 9 on the outside. We're trying to find the 4th root, so 16 to the 4th, or sorry, 2 to the 4th is 16. So 128 divided by 16 will get me 8. And 8 is 2 to the 3rd power. This can't be divided by 4, so it just stays as is. This one, I can make that into y to the 8th times y. So I have negative 9 out front. The 4th root of 16 is 2. I can't do the 4th root of 8. I can't do the 4th root of x to the 3rd. Divide 8 by 4 and you get 2. And I have a y underneath. So negative 18y squared and the 4th root of 8x to the 3rd y. Okay. This one, we went the 6th root. Okay. So I don't know that off the top of my head, but I do know that 3 goes into this. So we're just going to start at the very beginning. Oh, 9 probably goes into that. Let's start at 9. 729 divided by 9, I think is, 81. And then I have 3 and 3 here. Then I have 9 and 9 here. 3 and 3, 3 and 3. So how many 3s are there? 1, 2, 3, 4, 5, 6. So 3 to the 6th raised to the 1/6 would get you just plain old 3. Okay, so this one, we went to the 4th power. Well, we know this is 9 times 9. 3 times 3, 3 times 3. 3 to the 4th. And you're taking the 4th power of that. That will still get you 3. This one, I know for sure 2 goes into it. 4096 divided by 2. And that'll get me 2048. Oh, I think 4 definitely goes into that. Let's try 16. Oh, 16 goes into that 128. And I just guessed, guys. So this is 4 and 4. So 2 and 2, 2 and 2. 128 divided by 16. And that's 8. So this is 4 and 4. 2, 2, 2, 2, 2, 4, 2, 2. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 2 to the 12th raised to the 1/6. So if I multiply those exponents, I get 2 to the second power, which is 4. Okay, next. Okay. This is 5 times 5. So 5 squared raised to the negative 3 over 2. That'll get me 5 to the negative 3. Guys, because 3 over 2 times 2 is going to be get me 6 over 2, which is 3. So that will get me 1 over 5 to the third, which is 1 over 125. Okay, next. This one. Oh, this is 9 times 9, 3 times 3, 3 times 3. So I have 3 to the 4th raised to the 3/4. When I multiply that, the 4's cancel out. I get 3 to the 3rd power, which is 27. Square root of this. That's 2 times 49, 7 times 7, so 7 radical 2. Oh, this is 11 squared. Oopsie daisy. This is to the 4th squared. And see, why did I do that? Because this has a 2 in the denominator. I'm taking the square root. Need the exponents to be even. So if I multiplied by that 1/2, I would get 11. A to the second, A to the 1/2, B to the 1/2, C to the 1/2. So all the things that have, I should just highlight, all the ones that have the 1/2s, those should go first. So, I mean not first, they should go under the radical symbol. So A, B, C. To the 3rd power. Oh, can we simplify the fraction yet? No, we can't simplify the fraction. So 125 is, oh, you should know this. That's 5 to the 3rd power, A to the 6th, 3 to the 3rd power, B to the 3rd power. So we're finding the cube root, so we're dividing the exponents by 3. When I do that, I get 5, I get A squared, I get 3, I get B. Okay, now combining like terms, this and this are like terms. So 2 radical 5, this and this are like terms, so plus 6 radical 7. Over here, we need to simplify the radical first. So this is 4 times 2. So I get 4 radical 3 times 10 radical 2 plus 2 radical 3. And I'm going to multiply. So I get 4 radical 3 times 10 radical 2 plus 4 radical 3 times 2 radical 3. 40 radical 6 plus 8 times 3, because radical 3 times radical 3 gets 3, or the square root. The square root of 3 times the square root of 3. Awesome. Down here, I need to get a base of 4. So this is 4 times 4. So 4 equals, remember there's an exponent of 1. 4 squared raised to the x plus 2. The bases are the same, so I set the exponents equal to each other. 1 equals 2x plus 4. I subtract 4 from both sides. I get negative 3 equals 2x. I divide by 2 on both sides, and I get negative 3 over 2 equals x. This one. So I'm guessing 7 goes into this. Oops, why did it do that? So, this is 7 to the 3rd power. X minus 2. There's an invisible 1. Bases are the same, so I set their exponents equal to each other. 1 equals 3x minus 6. Add 6 to both sides, get 7 equals 3x. Divide by 3 on both sides and get 7/3 equals x. Okay, this one I need 4 on the denominator. I mean, not the denominator, the base. 256 is 16 times 16. So that's 4, 4, 4. So 4 to the 4th. So x plus 1 equals 4 to the 4th. Set the exponents equal to each other. I get x equals 3. Okay, word problem. Okay, the volume of a cube is v equals s to the 3rd, where s is the length of one side. What is the volume in simplest form? So we take volume equals 5x to the 3rd y squared and raise it to the 3rd power. So invisible 1, so 5 to the 3rd, x to the 9th, y to the 6th. So 125, x to the 9th, y to the 6th, units cubed. Okay, next, there we go. The volume of a pyramid is V equals 1/3 BH, where B is the area of the base and H is the height. What is the value of X if the volume of the pyramid in simplest form is equivalent to this? So I have X over 3 equals 1/3 the area of the base. So 16 to the 1/4 times 16 to the 1/4, because that's a square on the bottom, times the height, which is 27. Okay, so let's do some simplifying here. Some of you are like, oh, well guys, this is a regular number, this is a regular number. So how many times does 3 go into 27? Goes in 9 times. Oops, I wanted to do a different color. Goes in 9 times. So now that fraction's gone away. So 6 to the x over 3 equals, now 16, oops, I shouldn't be writing up there. I should be writing over here. Let's do 16. Oh, before I even do that, 16, I'm going to add my exponent. So that gets me 2 over 4. Well, guys, what is 2 over 4? Isn't that 1/2? Times 9. So now I get 16, or 6 over 6 to the x over 3 equals 4 times 9. 6 to the x over 3 equals 36. Well, can I get a common base on this? I'm gonna come over here. 6 to the x over 3 equals, isn't 36 6 squared? We have the same base now, so we just set the exponents equal to each other, multiply by 3 on both sides, get x equals 6. Okay, this next one, a manufacturer sells square trivets in various sizes. Oh, there's missing a Z. In the corner of each trivet sold, they engrave the company's logo right here. Okay, the diagram shows the ratio. The diagram shows the ratio of the size to each of the trivets. what is the ratio of the area of the trivet? So I want the area of the trivet to the area of the logo. Okay, so I need to find the area of each one of those. So the area of the trivet, okay, side squared, right? So 2r, and I'm going to square that. So that's going to get me 4r squared. The area of the logo, we have 6r squared. So the area of the logo is equal to 36r to the 4th. Now, this is asking for the area of the trivet, which is 4r squared over the area of the logo, 36r to the 4th. I'm going to simplify my fraction. 4 goes into 36 9 times. So now I have 1 over 9. If I have 2 r's on top and 4 r's on bottom, it gets me r squared. So that's my answer. Okay, next one. Mitchell is purchasing a new frame to hang on her bedroom. Okay, I've never heard of a girl's name is Mitchell, but okay. The picture frame is square shaped. What is the area of the interior of the picture frame in terms of C and D? Okay, it's a square. So the area of a square is side squared. So I take 5c to the 3rd d squared and I square it. I get 25c to the 6th d to the 4th units squared. Did I put squared up here instead of cubed? Nope, I put cubed. This one, a shipping box is in the shape of a cube. What is the volume of a shipping? Remember, length times width. Oh, is this a cube? Sorry. Side to the 3rd power. The side on here is 4m to the 8th, n to the 4th. We cube it. So 4 to the 3rd power is 64. M to the 24th, n to the 12th units cubed. The area of a triangle is 1/2 base times height. Okay, it tells us that the area is 6x to the 5th, y to the 3rd equals 1/2. We're finding the base times 4x to the 3rd y squared. Okay, let's deal with our fraction first. Let's deal with this. Get rid of that. So now I'm going to have 6x to the 5th y to the 3rd equals 2x to the 3rd y squared b. Now I want b by itself. All of this is multiplied, so I'm going to divide both sides by this. But this all cancels out. So 2x to the 3rd y squared. 6 divided by 2 is 3. X to the 5th over x to the 3rd gets me x squared. Y to the 3rd over y squared is y. And that is what is equal to b. Units, I guess, is what I should put on there. And maybe it's not working again. The area of a rectangle, length times width. The area is 32x y to the 3rd units, square units. Find the width. So the length is 8xy times w, and we're wanting w. So So I divide both sides by 8xy, 8xy. 4, the x's cancel out, and I get y squared is equal to w units. Okay, so the next one, it says the surface area S of a cylinder is square centimeters, can be this right here, where V is the volume of the cylinder in cubic centimeters, H is the height of the cylinder in centimeters. Find the surface area of the cylinder that has a volume of this and a height of that. Okay, so I'm replacing all the V's and the H's. So S equals 2. I'm replacing the V with 160 pi over, the height is 10, plus 2 pi, replacing the V with 160 pi over pi, and then the height, which is 10, and that's to the 1/2 power, and then the height is 10. Okay, so let's simplify this. So this cancels with this, and we get 16. So 32 pi plus 2 pi. 10 goes into 160 16 times. The pi's cancel out. So I'm finding the 1/2 power of 16 times 10. Okay, I'm going to come over here. And we have 2 pi times 4 times 10, because the square root of 16 is 4. So I get 32 pi plus, that's going to be 80 pi. So I get surface area is 112 pi units squared. Okay. So the next one, the base of the triangle measures 6 radical 2 meters, and the height measures 3 radical 6 meters. What's the area? So area equals 1/2 base times height. 1/2, the base is 6 radical 2. The height is 3 radical 6. So 1/2 of 6 is 3. So I multiply the numbers out front. I get 3 times 3. Multiply under here. I have 2 times 2 times 3. The square root of 4 is 2. So I get 9 times 2 radical 3. So the area is equal to 18 radical 3 meters squared. Okay, last problem. The length of the rectangle is 8 radical 10 centimeters. The width is 4 radical 8. What is the area? So length times width. So 8 radical 12 times 4 radical 8. Multiply the numbers out front and get 32. Underneath, 12 is 4 times 3. 8 is 4 times 2. So the square root of 4 times the square root of 4 is going to get me 4, or the square root of 16 is 4. We can't do those, so they are underneath. So this is going to get me 128 radical 6 centimeters squared.